talked about the basic rule of probability and we talked about complement rule. We want to now talk about problems involving OR in probability, right? So here we're saying, so if we're given probability of A or B, so the first thing to remember here is that OR means union. So whenever you see A or B, probability of A or B, we're referring to probability of A union B. So this is probability of A union B. And by this, we're referring to the probability of A occurring or B occurring or both occurring. So talking about the probability of A occurring or B occurring or both occurring. So probability at least one of the events is occurring. So whenever we're looking at probability of A or B, this is the probability of A union B, which is the probability that A occurs, B occurs, or both occur. So probability at least one of the events is occurring. And we can find this as probability of A plus probability of B minus probability of A intersection B. This is what we call inclusion exclusion principle or addition rule of probability or addition rule of probability, right? Or addition rule of probability. Now, in general, this is how you find the probability union of two events. We will look at a special case now, which is based on our axiom. Special case, if A and B are mutually exclusive events. Mutually exclusive events are those, the intersection is the null set. They don't have any common outcomes, they cannot occur together. We are mutually exclusive events. Probability of A intersection B is zero, right? Because A intersection B, if the mutually exclusive events is the null set, and probability of null set is zero. If A and B are mutually exclusive events, probability of A intersection B is the null set. So the above formula simplifies to, so in this case, probability of A union B simply simplifies to probability of A plus probability of B, because probability of A intersection B is just probability of null set, which is zero. So the idea is that if we just summarize what we did, that in short, in general, if you want to find probability of A union B, so in general, probability of A union B is probability of A plus probability of B minus probability of A intersection B, which is what the inclusion, this is what the inclusion exclusion principle or the addition rule of probability. Special case is that only if, now this is a special case that only if A and B are mutually exclusive events, only in this particular case, only if A and B are mutually exclusive events, which means the intersection is the null set. So probability of the intersection, which is probability null set, is zero. Only if A and B are mutually exclusive events, then probability of A intersection B is equal to zero. And if A and B are mutually exclusive events, probability of A intersection B, where intersection B is just the null set, probability of null set is zero. So then probability of A union B is probability of A plus probability of B. Right, so sum of individual probabilities, right? So in general, whenever you're finding probability of A union B, so this is always going to be probability of A plus probability of B minus probability of A intersection B. In the special case where we know that A and B are mutually exclusive events, then probability of A intersection B is just probability of null set, which is zero. Then in that case, we can simplify the probability of A union B as just probability of A plus probability of B as sum of individual probabilities. So Just keep in mind, or means union, and probability of A union B in general is probability of A plus probability of B minus probability of A intersection B. In the special case where A and B are mutually exclusive events, probability of A intersection B is just zero, and probability of A union B simplifies as the sum of the individual probabilities.